In a single afternoon, without warning, an entire planetary archive of accelerated ice melt suddenly disappeared. Imagine it, 45 years of meticulous, day-by-day satellite records documenting the radical transformation of our planet's polar regions, a priceless library of climate history, the bedrock for thousands of studies by scientists across the entire globe, just gone.
This isn't the plot of a disaster movie. It's what happened in early May when the White House effectively pulled the plug on one of the world's most critical climate databases. Today, we unravel the shocking story of how this essential evidence was destroyed. We'll expose the chilling political agenda that views climate science not as a tool for survival, but as an obstacle to be removed.
And we will explore the profound irony of a government blinding itself to a crisis it simultaneously seeks to exploit for profit and power. What happens when we are forced to navigate the future with our eyes wide shut? Since the White House slashed $1.7 billion from the budget of the National Oceanographic and Atmospheric Association, better known as NOAA, and fired a tenth of its highly specialized staff, the headlines have focused on the immediate, terrifying consequences. The move was a catastrophic disinvestment in disaster preparedness, coming just before deadly floods ravaged Texas and brutal heat waves scorched the Northern Hemisphere. But beneath those headlines lies an even more insidious story. The true bombshell was the decommissioning of NOAA's National Snow and Ice Data Center databases, including its legendary Sea Ice Index. This wasn't some obscure dataset for academics alone. The Sea Ice Index was the public face of the Arctic crisis, the source of those shocking charts and graphs that showed the cryosphere shrinking year after year. And then it vanished. Morven Mulewick, a climate scientist and oceanographer at the Norwegian Polar Institute, put it bluntly, this is a huge blow to science. Worryingly, a lot of the world's critical climate data is being stored in data centers in the US. This highlights a staggering vulnerability. The world's shared understanding of our climate is hostage to the political whims of a single nation. For those on the front lines of Arctic research, this felt like a horrifying case of déjà vu. The scientific world was still reeling from another major blackout. After Russia's invasion of Ukraine in 2022, Western sanctions targeting Moscow severed crucial scientific cooperation. This wasn't just a political decision. It was a schism that tore through the scientific community. Overnight, half of the geographical Arctic went scientifically dark. Instruments across the vast Siberian expanse were abandoned. Decades-long studies began logging terrifying blanks. Vital data networks went offline, and once daily contact between close colleagues went silent. But this new American-made blow felt different, and perhaps even more cynical. The Russian shutdown was a consequence of geopolitical conflict. This felt like a direct, ideological assault on knowledge itself. The modern era of climate science was born from a rare moment of post-Cold War optimism in the early 1990s. The Arctic Council, an unprecedented agreement, united the 8 Arctic nations and 6 indigenous organizations in a shared mission of research and environmental protection. For a time, it seemed cooperation might define our approach to the top of the world. But that dream came to a screeching halt. Now, the question looms larger than ever. Will conflict or cooperation define the next era of polar politics? Few imagined the next great assault on that cooperation would come not from a geopolitical rival, but from the United States itself. While Russia may dominate the Arctic map geographically, the United States has long been its undisputed research powerhouse. A 2024 analysis by UArctic concluded that not only is the U.S. the world's greatest public funder of Arctic research, but that American institutions publish the most content on Arctic topics and participate more than any other nation in cross-border collaborations. At the heart of this powerhouse was NOAA. Its fleet of 17 satellites didn't just power weather forecasts. They built the definitive archive of our changing planet. The Sea Ice Index, in particular, became a global icon of the climate crisis, not just because sea ice is a vital climate regulator, but because it's melting far more quickly than anyone ever predicted.
You cannot tell the story of our time, the Anthropocene epoch, without talking about sea ice. The planet's icy poles act as a global air conditioning system, their white surfaces reflecting sunlight back into space and chilling the oceans. As greenhouse gases began to melt that reflective shield, millennia of stable climate patterns went haywire. Dark, heat-absorbing water replaced the ice, creating a vicious feedback loop that accelerates warming, disrupts weather systems, and unleashes new extremes across the globe. And the Arctic is the epicenter of this change, with temperatures rising at a staggering 4 times the global average. We know this, in large part, thanks to the now-defunct NOAA database. We know that in 2007, the Arctic sea ice shelf suffered a catastrophic collapse, permanently wiping out 38% of the summer ice in a single season.
We know that every year since, the Arctic has lost an average surface area of sea ice equivalent to the state of Maryland, and we know that this trend is accelerating. So why would anyone want to destroy the evidence? The answer can be found in a political action plan called Project 2025, authored by the Heritage Foundation, whose writers now occupy positions in government. The blueprint explicitly calls for dismantling NOAA.
It labels the agency a colossal operation that has become one of the main drivers of the climate change alarm agency, one that is harmful to future U.S. prosperity. It's a truly staggering contradiction, isn't it? Demolishing the tools that warn us of danger, all in the name of prosperity. If you find this deep dive into the high-stakes politics of ice as revealing as we do, please hit that like button to show your support. The irony becomes even more profound when you look at the administration's other plans for the Arctic. The same leaders who defund climate science are intensely interested in the region for what they call national security and economic opportunity. There's the well-publicized desire to buy Greenland and a keen focus on new shipping routes, untapped resources, and strategic military positions, all of which are only becoming available because the Arctic is shedding its ice at record rates. This is the Great Arctic Paradox. As the ice melt makes the region more ecologically vulnerable, it creates a frenzy of commercial and military interest. The story has been building for decades. In 2005, the Arctic Council's first Arctic Report Card placed the High North at the center of the global climate story. 2 years later, the same year the ice shelf collapsed, Russian explorers planted a flag on the North Pole seabed, a symbolic claim to the region's vast energy reserves. By 2009, a NOAA report, yes, the same NOAA, predicted that Arctic melt would expose up to 40 million new tons of oil and gas. That report was a turning point. Suddenly, the once obscure Arctic Council meetings became a key diplomatic stage. In 2012, Secretary of State Hillary Clinton attended, the highest-level American official to do so. A year later, 6 new observer states, including China, Japan, and India, were added, recognizing their growing interests in a melting North. By 2018, China unveiled its Polar Silk Road Initiative, a breathtakingly ambitious plan to capitalize on the moment an ice-free Arctic would unlock record-fast shipping routes. This wasn't just about faster delivery times. It was a clear signal of intent to reshape global trade arteries and project power into a newly accessible and competitive zone. Some politicians argue that we already know everything we need to know to act on climate change. A Norwegian official characterized the loss of Russian science as regrettable but abstract, saying, "We know what we need to know in order to act." But climate scientists say this is a dangerously simplistic and outdated view. Yes, the expert consensus on the need to cut emissions is clear, but we are long past the point where emissions reductions alone are sufficient. With climate change already here, our best hope lies in adaptation and mitigation. And our ability to adapt depends entirely on our ability to predict, with increasing accuracy, what is coming next. And the biggest uncertainties in those all-important climate models cluster right around the Arctic. Morven Mielwick explains that the next generation of climate modeling is moving in a hyper-regional direction. It's no longer just about predicting the broad strokes of a few degrees of temperature rise. The crucial questions are now far more specific. As sea ice changes, how is that going to affect Scandinavian weather?
That's a very different question than how is it going to affect weather in the Sahara? People need specific, localized knowledge to prepare, and that's where the most advanced work is going now. And where does that work happen? It all comes back to NOAA. The agency's Geophysical Fluid Dynamic Laboratory is responsible for some of the world's most powerful, high-resolution climate models.
It also runs the project that helps bring different models from around the world together to cross-check and improve one another. The next IPCC report will have to rely on this computational power, which is now at risk. Mulwick's team in Norway has been frantically downloading other NOAA datasets, performing rescue missions just in case more archives disappear. But the data alone isn't enough.
Mulewijk compares a climate model to a complex Google product, constantly sustained and improved by thousands of employees. If you take some of those people away, he says, it's not an on or off switch. We don't know the impact. You just know the system will start to degrade, to fail in unpredictable ways. One morning in mid-May, about a week after the NOAA cuts, the author of the original article woke up adrift in a field of sea ice.
She was aboard the Dana, a Danish research vessel, with a team of 20 scientists. After 3 days of sailing north, she was awakened by a sudden, eerie stillness. Opening her porthole, she felt like she was on another planet. It's important to understand this wasn't icebergs, which are chunks of freshwater glaciers that calve into the sea. This was sea ice, which forms directly from the ocean's surface and has an entirely different crystal structure.
It is the sea itself, merely in a different state. For miles in every direction, countless, tall piling, blue glowing, lopsided structures of ice drifted and rotated, colliding with a deep, resonant sound. Some chunks were as large as sailboats, their slow, heavy movements hinting at immense mass hidden below the surface. Dark-spotted harp seals slipped down their sides. Other pieces were flat and broad like saucers, with dozens of seals lolling on their twinkling, snow-dusted surfaces. It was breathtaking, and it was a wake-up call. Gazing at those innumerable, utterly unique forms, she realized that as a journalist, she had been writing for years about something she fundamentally did not understand. In describing the ice as if it were already gone, a tragic victim, she had missed what it still is. It's a dynamic, shape-shifting system that travels fast and far with the currents. Before, she had seen photos of fractured ice and assumed it represented only loss. But the ice is always fractured. It forms piecemeal across the vast winter ocean, then melts, mixes, and migrates for the rest of the year. Despite its depleted state, its sheer scale and speed were powerful beyond imagination. Picture it, hundreds of kilometers of a land-like mass that can migrate hundreds of kilometers in a single day. The research ship experienced that power firsthand. The whims of the ice dictated their every move, forcing them to check satellite data every 12 hours to see where they could safely steam. This constant checking changed her worldview. As the center of her internal map shifted north, the movement of the ice became the frame for her entire reality. She began to wonder, what if more of humanity had to check on the sea ice before making major decisions? And more pointedly, who benefits from convincing us that it's already gone, that it's unsavable? Scientists may know more than we do, but much about sea ice remains a profound mystery, even to them. It's historically understudied because it's remote, expensive, and dangerous to research. It's one of the planet's most dynamic ecosystems, supporting everything from microbes to polar bears, constantly interacting with the ocean and atmosphere. Now, it's also one of climate science's greatest challenges. As Mulewijk put it, we're getting better at the understanding and the science, but as we're getting more and more data, the system is also changing. You're studying something that's changing so fast that you can barely keep up with your own research. Most of us will never see sea ice with our own eyes, so it may feel difficult to weigh the loss of an abstract dataset like the Sea Ice Index against the loss of a hurricane prediction tool. But this loss is no abstraction. Every single organism on this planet will be affected by what is happening in our northernmost ocean. In the vast, interconnected system of global climate, the fate of the cryosphere, the part of the Earth's surface covered in frozen water,
will play an outsized role in a magnitude of catastrophes coming for our nations, our cities, and our homes. The ice is connected to all of us, and it connects all of us in a shared climate fate. We ignore it at our own peril.
To ensure you don't miss our next investigation into the stories that are shaping our planet's future, be sure to subscribe and ring that notification bell. Let's stay informed.